The Webb findings are so far out that the light we're now receiving has been traveling for in excess of 13 billion years. Anyway, the universe has been growing. Furthermore, the light has been stretching. For the most far-off worlds, we're looking back in time almost to the Big Bang. The vastness of the universe could appear huge, but every single piece of it started from what we allude to as the singularity. At this point, this is how we interpret the Big Bang Theory, at any rate. The James Webb Space Telescope, JWST, has uncovered huge secrets about the birth and advancement of the universe, leaving us confounded. Renowned physicist Brian Cox has declared that the striking discoveries made by the JWST could reshape our view of the universe in general. Join us as we dive into these new heavenly revelations that promise to disturb our understanding. The James Webb Space Telescope, named after the recognized NASA administrator James E. Webb, stands as a miracle in modern cosmic exploration. This telescope represents an immense technological leap forward from its predecessor, the Hubble Space Telescope, coming to fruition due to a helpful effort between NASA, the European Space Agency, the Canadian Space Agency. The JWST outperforms the capabilities of its envoy, its cutting-edge technology, and a design optimized for studying the universe in amazing detail. Unlike the Hubble, the JWST delivers clear and sharp pictures of far-off celestial bodies. Working primarily in the infrared range, this unique feature allows it to penetrate massive dust clouds and capture celestial objects that were previously hidden from our view. With its tremendous 6.5-meter primary mirror made from 18 hexagonal segments, the JWST dwarfs the Hubble's mirror in size. Located about 1.5 million kilometers away from Earth at the second Lagrange point L2, it orbits the Sun in a state of harmony with the Earth, ensuring a steady and continuous view of the universe. While investigating the far-off corners of space, investigating light years away also involves a form of time travel. The JWST uses infrared instruments to observe celestial objects and events from billions of years ago. The light emitted by these objects due to the expanding universe undergoes a redshift shifting from the visible spectrum to the infrared spectrum, or longer wavelengths. Fortunately, the JWST can detect this infrared light emitted by celestial bodies spread out far enough for scientists to study the birth of stars, explore galaxy formation, and examine exoplanet climates. Its most recent outstanding discovery includes identifying galaxies at the edge of the observable universe. This finding challenges the validity of the Big Bang Theory, prompting a reassessment of our fundamental cosmological assumptions to better understand how we arrived at this point. Let's take a short journey through the history of space exploration. Early developments, like those of the Greeks and Chinese, laid the groundwork for understanding planetary motion by observing celestial bodies. Newton's laws in the 17th century provided a theoretical framework for space travel. At the beginning of the 20th century, Edwin Hubble, a renowned space expert, made groundbreaking discoveries in cosmology and observational astronomy. His observations revealed that distant nebulae were separate galaxies, far beyond the Milky Way, changing our understanding of the universe's size and expansion. According to Hubble's law, galaxies farther away were receding at higher rates, providing evidence for the expansion of the universe. The post-World War II era marked the beginning of the space race, with the Soviet Union's Sputnik in 1957 as the first artificial satellite in orbit, Yuri Gagarin's orbital flight in 1961, and the Apollo 11 moon landing in 1969 as landmark achievements. Fast forward to 1990, when the Hubble Space Telescope was launched, providing astonishing clarity and dazzling insights into the universe. The transition from early observations to the technological marvels of the James Webb Space Telescope highlights the ongoing improvement in our understanding of the universe. It uncovered the vastness of space and transformed fundamental ideas in cosmology. Take the Hubble Space Telescope, it's also known as HST. It captured the famous Pillars of Creation image in the Eagle Nebula, revealing a stellar nursery formed by large columns of gas and dust. Another image, the Hubble Deep Field, encompassed thousands of galaxies in a region of space that appeared to be empty. The HST also delved into exoplanet environments, pinpointing components like water and organic molecules in distant worlds, hinting at the possibility of habitable zones beyond our solar system. Following the discovery of the nearest observed supernova, SN 1987A, it shed light on the life cycle of massive stars. These achievements solidified the Hubble Space Telescope's legacy as the basis of modern space science. Captivating the world with its stunning cosmic revelations, its successor, the James Webb Space Telescope, was launched to build on technological advancements and lessons learned from Hubble. One example is our understanding of the universe's origins, which today is explained by the prevailing theory of the Big Bang. Around 13.8 billion years ago, the universe began as a dense hot singularity, rapidly expanding and leading to the creation of matter, energy, and fundamental forces. As the universe expanded, it cooled, leading to the formation of molecules, stars, galaxies, and the various structures observed today. The Big Bang theory also explains cosmic microwave background radiation, element abundance, and the large-scale structure of the universe. Despite its broad acceptance, the Big Bang theory faced skepticism and challenges in its early stages. Other models, such as the steady-state theory, proposed a universe without a specific beginning. Concerns arose about the evidence supporting the initial singularity, the expansion mechanism, and observed anomalies. Many of these issues were addressed over time, the crucial piece of evidence coming with the discovery of cosmic microwave background radiation, conforming to Big Bang predictions in 1965. Space missions like COBE and WMAP, along with technological advances, further supported the theory. Accurate measurements of cosmic microwave background radiation matched theoretical predictions astonishingly well. Enter the James Webb Space Telescope, equipped with advanced infrared instruments capable of peering through cosmic dust clouds. Operating primarily in the infrared range, the JWST captures the oldest light in the universe, serving objects formed shortly after the Big Bang. Its infrared capabilities allow it to focus on star-forming regions, stellar nurseries, and the birth of stars that are obscured from optical telescopes. Infrared light, with longer wavelengths than visible light, can penetrate interstellar dust clouds, overcoming a limitation of the Hubble Space Telescope. The JWST can detect cooler objects emitting primarily in infrared, making it ideal for studying phenomena like exoplanets, brown dwarfs, and distant galaxies. As celestial bodies emit light, it stretches as they move away, causing a redshift. The JWST's infrared capabilities identify these redshifted signals, capturing light from the early universe and offering insights into its evolution and development. Black hole formations or new star births predominantly emit in the infrared, further expanding JWST's observational capabilities. The telescope can investigate phenomena that would otherwise remain hidden, whether physically or invisibly. The JWST supplements optical telescopes like Hubble by offering enhanced sensitivity and the ability to detect infrared radiation. This ability allows it to peer deeper into space and delve further into cosmic history, uncovering hidden cosmic mysteries and providing a broader view of the universe's evolution. The JWST serves as our window into the earlier stages of cosmic development. Recently, it revealed something so extraordinary that it could lead to a reassessment of the entire cosmological model of the universe. We've discovered large masses of galaxies at the very edge of the observable universe. These ancient galaxies existed only a few 100 million years after the Big Bang, marking the dawn of the universe. The surprising part is that we're uncertain how such massive structures formed so early in the universe's history. This discovery may lead us to re-examine our understanding of the formation and evolution of galaxies in the early universe. Studying early galaxies is essential for unraveling the mysteries of the universe's beginnings. The JWST can provide insights into how galaxies, stars, and planetary systems formed over the course of billions of years. These observations also contribute to broader questions about the fundamental nature of the universe, including its composition, structure, and the forces governing its development. While the Hubble Space Telescope was crucial for its time, it had limitations in observing the early universe. Its primary limitation was its inability to effectively penetrate cosmic dust and detect the infrared light emitted by ancient galaxies. Older telescopes relied on visible and ultraviolet light observations, making it challenging to explore the early universe, where these wavelengths are absorbed or distorted by cosmic dust and gas. The James Webb Space Telescope represents a remarkable leap in observing galaxies from the universe's earliest stages. Unlike its predecessor, the JWST can observe celestial objects that formed within a few hundred million years after the Big Bang. Using its infrared sensitivity and advanced imaging capabilities, the JWST has uncovered a wealth of ancient galaxies, offering exceptional clarity and detail. In understanding the universe's transformative history, initial discoveries from JWST observations have stirred waves in established cosmological models, providing detailed data that challenges several aspects of prevailing theories and prompting cosmologists to reconsider core principles governing our understanding of cosmic structure and evolution. Discrepancies between observed data and theoretical predictions have sparked intense debates among scientists. JWST observations have revealed more galaxies in the early universe than predicted by existing models, suggesting a more complex and rapid development process. Some observed early galaxies appear more mature than expected, challenging traditional models that predicted slower development. The discovery of a massive number of galaxies challenges the predicted distribution and arrangement of large-scale structures, revealing a more intricate and denser cosmic web than previously thought. These observations raise intriguing questions, and the existence of massive structures challenges early models of large-scale structure formation, prompting scientists to refine models for a better explanation and a comprehension of how such massive structure accumulated so soon after the Big Bang. This presents a puzzle that requires an updated framework of cosmic evolution. Ultimately, the James Webb Space Telescope provides unprecedented access to the deepest corners of space. It has the potential to uncover new cosmic secrets, compelling us to reconsider our perceptions of the universe's formation, development, and vast interconnectedness. Recent findings from the JWST have ignited curiosity and challenged previously held beliefs about the early universe. For example, some of the most distant galaxies observed by the telescope appear much more advanced than anticipated for their age, suggesting that the processes that governed their formation were more rapid and complex than expected. This is changing our perception of galaxy formation and the timeline of cosmic evolution. One of the most profound implications of these observations is the reconsideration of the cosmic dawn, the period when the first stars and galaxies formed. Shortly after the Big Bang, the JWST's ability to look back in time and capture light from these distant objects makes it possible for researchers to study conditions that led to the formation of the first galaxies, stars, and black holes. This research could provide crucial insights into the nature of dark matter and dark energy, which are still largely mysterious. Moreover, the telescope's infrared sensitivity is enabling astronomers to investigate regions of space previously obscured by dust. These regions, such as star-forming nebulae and the hearts of galaxies, are now visible in stunning detail. By observing these areas, scientists can better comprehend the processes that drive star formation and the evolution of galaxies over billions of years. The JWST findings have also provided important clues about the formation of planets outside our solar system. Its ability to study the atmospheres of exoplanets is helping scientists determine whether these distant worlds could potentially support life. By recognizing substances like water vapor, carbon dioxide, and methane, the telescope is painting a more complete picture of the conditions that might make an exoplanet habitable. While the findings that the JWST has made are incredibly exciting, they also raise new questions. For instance, the existence of galaxies that are more mature than expected in the early universe challenges current models of galactic evolution. How did these galaxies form so quickly? What processes were at work to accelerate their growth? These are questions that will drive future research and likely lead to even more discoveries about the fundamental nature of the cosmos. Furthermore, the JWST is providing an unprecedented opportunity to explore the nature of dark energy, a mysterious force that is causing the accelerated expansion of the universe. By investigating the pattern and distribution of galaxies at great distances, scientists hope to uncover more about this enigmatic force and its role in shaping the universe's fate as we continue to push the boundaries of space exploration. JWST is providing us with a deeper understanding of the cosmos, one that may challenge existing models and open up entirely new avenues of research. With its groundbreaking technology, the JWST is more than just a telescope, it is a time machine that allows us to peer back into the distant past, providing invaluable insights into the origins and evolution of the universe.